So while we are all in here at one time, make sure that your volume is down on your laptop so you don't have any feedback. No hot mics. Yeah. Yeah, you can say Dr. Hartsorn or Dr. Hartsorn. Yeah. It doesn't need to be super formal. Okay. He doesn't really seem like a super formal person. So, yeah. All right. I'll start putting this rolling into channels now. Dr. Green, your camera is on.
Thank you.
And then we have co-hosts. And so Nick and Ray, they just switched up a little bit. Well, I guess they haven't really. So I'm still going to go through. I think it's Dr. Green.
What's going on?
The microphone.
Hi.
Hello, Kathy.
Hi.
How are you doing today?
Good. I'm excited for this event.
We are very excited to host all of you. We see a lot of people are populating the attendee list. Looking good. Tony, do you want to go ahead and test your mic?
Yeah, how's my audio?
It is wonderful, thank you.
Is mine okay too, or should I go to the iPods?
Yours is good.
It's okay? Okay,
Yeah.
good. How are you doing, Tony?
Take a crazy guess. I'm
3
living
more
the dream.
weeks? 2 more weeks?
There is the bitter end of the spring, and my students are completely out of gas. Like, it's weird. I'm extra buoyant. Let's just say it's COVID-19 vaccine related, and then they're like extra down in the dumps. So it's hard.
Yeah, nobody got spring break to refuel or recharge or do anything.
No, that's true. So I offered them, I think the first week of the semester, I heard some people were doing quote unquote wellness days. So we've had 2 of those so far, and we have 2 more to go. So that'll get them 4 of the 5 that they wanted.
Okay.
I know it's not the same though. How are you doing?
I'm fine. I'm mainly just doing research now. I didn't teach this semester, so that's great.
That is awesome.
Yeah, it's totally fun. Did you guys get your grant for looking at the Bridger fires?
Even worse. We got ghosted by the program officer. I mean, I've asked her a couple times what's going on. It was a rapid. There's supposed to be like 4-week turnaround. It was a 3-page proposal, but I'll ask her when I get my head above water next week. I think we're going to try to flip it to NASA. So anyway, let's catch up later.
Yeah.
I'll come find you upstairs.
Try and find me upstairs is the question.
That's good.
Good afternoon, everyone. I am Calista Schottmer, the chair and co-founder for this event, and I want to thank you from the bottom of my heart for joining us here for AIChE's second annual climate conference. There are a few key lists of people that I'd like to thank today. One are the sponsors who have made this event free and accessible to all. The second is our group of talented speakers who have agreed to donate both their time and expertise to the conference. Student volunteers who have made our breakout sessions possible. And the group of students who has been planning this event for nearly 2 years, who spent a lot of time breathing life into this conference at the good of our community, which brings us to the last group that I would like to give thanks to, and that is all of you. So our audience ranges from our more local faculty and staff who have supported us from day one, students sprinkled throughout the state and alumni, and then also to some of our connections throughout the country with AIChE's Rocky Mountain region, American Conservation Coalition, and we even have a supporter from Penn State. One of our favorite answers that came through was retired climate scared folks. And I can't hear or see you all right now, so I'm just going to pretend that you let out a little chuckle there, but I'm happy if that strikes a chord with you because it kind of symbolizes why all of us are here. There is something within us that induces fear, and the topic of climate change transcends the demographics of all the people here and unites us with the one goal, and that is to see how we can do better. So this is a lot to tackle over Zoom, but the leadership team that I was just telling you about spent a lot of time curating a program that balances learning about climate from many scientific perspectives, while also making sure everyone has a chance to contribute to discussions throughout the conference. We are doing this by going back and forth between presentations from our speakers, then small discussion sessions, and then topping the conference off with a final panel that is fed questions generated in the breakout sessions. In order to do this, we have a few different links you'll have to follow that we sent out in the instruction emails, but we will also send the necessary links in the chat of whichever Zoom meeting we are in at the time. I would now like to introduce you to one of our leadership team members, Nick, who will give you some tips on how to appropriately navigate Zoom.
Thank you, Callie. So for this Zoom conference, we really want to make sure that we can get the most out of it through this platform. And there's a couple of things we can note there. In the current presentation mode that we're in, you actually won't have access to cameras and microphones, but we'll be intermittently going into our breakout rooms. And especially in those, we want to know how we can best use the platform to get the most out of the conference. So as far as cameras, those will be available, and it'd be great if you can engage in the breakout rooms and turn those on so we can have good discussions, but then also be mindful of what's around you and what's in your background. Same with microphones, you'll have the option to have those on in our breakout rooms, but we want to make sure that you leave those off and turn them on only when you're speaking. And also when you do use your microphone, make sure that you're paying attention to what's around you and background noises and limiting those as much as possible. And then a general note, it's easy to get distracted when we're on our computers with Zoom, so do our best to limit distractions and multitasking so we can make the most out of this conference and get out of it what we want to. Thank you.
Hi, everyone. So as Callie mentioned earlier, since this is a virtual conference, our team wanted to incorporate the opportunity for attendees to still engage, interact, and really feel a sense of community. So each breakout session will last about 5 minutes and happen after each presentation. A few reminders as far as the expected etiquette is that we'd like to make the space for everyone feel heard and to resist interrupting or intentionally talking over others so that we can be conducive of learning, collaborating, and connecting with other attendees. Along with that, respect fellow participants, actively listen and engage in conversations, share your own thoughts and reflections rather than making statements directed towards others. And after each session, the goal is to walk away with a formulated question for the Q&A panel that will be hosted with all of the presenters. And one final note is that the breakout sessions will have separate links from the main Zoom webinar, so be sure to click on those and they will take you where you need to go.
Thank you, Nick and Ray, for teaching our participants a little bit more about how we are utilizing Zoom throughout this meeting. I would like to now hand it over to another leadership member, Teddy, who will introduce our first speaker.
Thank you, Callie. I have the pleasure of introducing our first speaker today, Dr. Kathy Whitlock. Dr. Whitlock is a Regents Professor in Earth Sciences at Montana State University and a Fellow of the Montana Institute on Ecosystems. She is also the lead author of the 2017 Montana Climate Assessment. Dr. Whitlock's research interests include past climate change and paleoecology with a focus on vegetation, fire, and climate history. She is nationally and internationally recognized for her scholarly contributions and leadership activities in the field of past climatic and environmental change, and she has published over 200 peer-reviewed journal articles and book chapters on this topic. She is a Fellow of the Geological Society of America and the American Association for the Advancement of Science, and she was elected to the National Academy of Sciences in 2017. Ladies and gentlemen, Dr. Whitlock.
Thanks, Teddy. And thanks, Callista and the chemical engineers at MSU for hosting this event. And for you in the Zoom audience, thank you for what I think is going to be some good discussion in the next day. You know, you and I are on a journey together, and it's a long journey. And in a couple of decades, we're going to come to a crossroads where the path that we're on is going to break into several paths. And each of these paths will lead us to different outcomes and offer very different futures for the planet. The rub is that we have to make the decision now, sight unseen, as to which path to take. And the only information to guide this decision comes from scientists and other pundits. So it's not a comfortable position to be in. What will the consequences be of our decision for our lives and our children and our children's children? That's the situation that we're facing with climate change. And the paths that we're looking at are different levels of greenhouse gases in the atmosphere. We have been steadily increasing greenhouse gases for the last 140 years. And right now we're at the point where as we go to the next 20 years or so, we're going to be on pretty much the same trajectory of greenhouse gases. But at 2040, 2050, we're going to bifurcate and we could go in any number of directions. And it's going to depend on things like how much greenhouse gas do we emit from the burning of fossil fuels versus how much carbon do we store. So if we can get a handle and reduce greenhouse gas emissions, we can kind of flatten this curve or maybe even send it back to the negative. But if we're going on the trajectory that we are now, we're going to have this very sharp, steady increase. And as you know, each of these CO2 trajectories, how much greenhouse gas we have in the atmosphere, determines how much warming there is in the atmosphere. So global warming is directly caused by greenhouse gases. I've been involved for a while now in doing assessment work for Montana and the region. And the reason I do that is because I think it's really important to get information on the ground to people who are making decisions. And we also understand what's happening in our backyard, not just globally. So the first assessment was the 2017 Montana Climate Assessment. This was done with a big team of people, and we focused on the impacts of climate change on water, forests, and agriculture. More recently, we released a report on how climate change is going to impact human health in Montana, and this was done with climate scientists and healthcare professionals. And coming in June, and I'm super excited about this, is we're releasing a very high resolution assessment of what climate change is going to mean in the greater Yellowstone region. So this is the 3-state area that has Yellowstone National Park at its core and includes Bozeman. So all of these assessments are available online. Go to montanaclimate.org, and they're resources that hopefully everyone can find and use. So I want to talk a little bit about the findings from the forthcoming assessment, because what you're doing now is always the most interesting. When we look at the greater Yellowstone region, we can already see that climate change is happening. Since 1950, it's gotten about a little over 2 degrees Fahrenheit warmer. Snowfall has declined dramatically, especially below 8,000 feet. And stream flow keeps coming. The day of maximum stream flow keeps coming earlier and earlier in the year. Now it's about 8 degrees earlier than it was in 1950. When we look at temperature change for the whole region, you can see the implications of these different pathways of greenhouse gases. So the black line is the historical record of temperature change. And you can see from 1950 to about 2020, this increase that we've already seen. But at 2040, these two paths will split. And if we go on the sort of business as usual path, or the extreme case, we could see as much as 10 degrees Fahrenheit warming by the end of the century. 10 degrees Fahrenheit warming in annual temperatures is a lot. On the other hand, if we're on the trajectory that involves some mitigation of carbon, we can flatten this curve and perhaps keep the temperature levels at about what they would be at mid-century. So about a 4 to 6 degree Fahrenheit warming that sort of persists through the rest of the century. This has a lot of implications for snow versus rain, because that's very much a temperature-driven phenomena. So this is a graph of the greater Yellowstone area, and we're starting in 1950 on the left and going to the end of the century on the right. And I'm plotting the elevation of snow versus rain for different elevations. So this is in meters. Green is the elevation of rain, blue is the elevation of snow, and the reds, orange, and yellows on this graph are the elevation of slush, that kind of weather that we all hate. And what you can see is that snow elevation, snow line was at about 6,000 feet, 2,000 meters in 1950, but it's steadily increasing, so that by the end of the century, it'll be up at 11,600, about 3,600 meters. That's simply being driven by temperature. We're getting about the same amount of precipitation, but as it gets warmer, less snow, more rain. And you can see that on the map. So the blue is the area of snow in the greater Yellowstone area in 1990. This is the area of snow in 2040, 2070, and this is the end of temperature, the end of the century. Simply because it's getting warmer, there's less snow. People often ask me, well, are the changes that we're seeing now precedented? In other words, have they occurred in the past, or are we seeing something that's completely unusual? I love that question because it's actually what I do in my research. I study past climate change, and let me give you a little bit of background. In Montana, if you want to understand past climate change, you either have to use tree ring records or the sediments of lakes. Lakes are great repositories of environmental information, and everything that falls on the surface of the lake has the potential to be buried in the mud. So we go to these lakes and we get vertical tubes or cores of sediment. And as you can imagine, the top layer was laid down just recently, but we can go back layer by layer through time to the bottom layer in our cores, and we'll see what it's like at the beginning of the lake. Most of the lakes in Montana that we study formed about 15,000 years ago at the end of the last ice age. So that's a very long period to study environmental change. We take these sediment cores back to the lab, we split them open, we describe the sediments, we take samples from top to bottom, and we treat those samples with different chemicals. And then we look at the residues under the microscope to see what's there. And from being a kid to being an adult, there's nothing more fun than looking at what's in the mud. Our group specializes in fossil pollen grains. Different plants produce different looking pollen. And when you can identify the pollen, you know what plants were growing around the lake in the past. Assemblages of pollen tell us about past vegetation. And when you know the vegetation, then you can reconstruct the climate. We also look at black particles of charcoal that are in the mud because these tell us about the occurrence of ancient fires. Honestly, we look for anything we can find in the mud. Sometimes it's pieces of bone, sometimes it's insect parts. Each of these discoveries helps us reconstruct what the ancient environment was like. So here's a record of climate change going back 11,000 years based on pollen data. Pollen data not only from my sites, but from the Northern Hemisphere. So 11,000 years is on the left and present day is on the right. And this blue line is the average temperature of the last 11,000 years. What you can see is that from 11,000 years to about, 7,000 years, the temperature's been steadily rising. This is the end of the last ice age. The glaciers are retreating, the forests are moving in. The climate sort of stabilizes, but in the last 5, 6, 7,000 years, it's been getting steadily cooler. Okay, so that's the pattern: rapid warming, then steady cooling. Okay, this is more or less the last decade. You can see it's way above the average for the last 11,000 years. And this is 2016, which is warmer than almost any of the samples that we've seen in the last 11,000 years. So yes, on a time scale of 11,000 years, we are in a period of unprecedented climate change. We can take that farther back in time by looking at ice core records. Ice cores that are taken from Antarctica go back right now 800 to 800,000 years ago. And in those ice cores, they can not only look at proxy that tell them about temperature, but also measure directly the CO2 levels that tell us what the CO2 composition was like in the atmosphere. And what we find is that times when it was warm, so 800,000's on the left, present day's on the right. Times when it was warm were times when there was a lot of CO2 in the atmosphere. Times when it was cold, there's less CO2 in the atmosphere because, as you can imagine, it's in the ocean. There's about 8 of these sort of up and down periods, which we call glacial when it's cold and interglacial when it's warm. And we're in a present day interglacial. Notice there's a bound of variability in these data, that you don't get extreme values of temperature or extreme values of CO2 during each of these glacial interglacial cycles until now. Now we're at 415 parts per million. We're way above that envelope of variability that we've seen for the last 800,000 years. So yes, we are in unprecedented times. As a geologist, I think, well, what was it like at 400? What was it like, and when was the last time we had CO2 levels at 415 parts per million? Well, for that information, we go to the ocean records. This is a long ocean record showing ocean temperature for the last 5 million years. So 5 million's on the left, present's on the right. This blue box is the time frame of the ice core record, so you can see the up and down of the glacial periods. The last time we had CO2 at 415 parts per million was in the Pliocene, which is 3.5 million years ago. And we know that during that time that the temperatures globally were 6.5 degrees warmer than they are today. It was extremely warm at the poles, so there were no polar ice caps. And when I look at the pollen that from Pliocene rocks, the pollen looks like the kinds of plants in Montana were similar to what we would see in South Carolina today. So the vegetation was very hot and humid. Not a bad place, but a very, very different place. So I think it's fair to say that current climate change is unprecedented for at least 3.5 million years. Well, what does climate change mean for us in this region? First of all, we know from the paleo record that anytime the climate's changed in the past, species have had to move or adapt or go extinct. That's what's happening now. Grizzly bears are on the move, wolverine populations and white bark pine populations are declining, toads and frogs are having a hard time, and migratory birds are even coming in before their food sources are available. We're going to have to live with wildfire. Anytime in the past it's been warmer, we get more fires. There's this very direct relationship between fires occurring when temperatures are warm. We thought the fires in Yellowstone in 1988 were a really big deal, but we've seen larger fires almost every year somewhere in the West since then. So fires are in our future. And as humans, we're going to have to live with a lot of uncertainty. Think about it. Warmer temperatures means less snow. The snow will turn to rain. The snow will melt sooner, and we're going to go into summers being dry. This puts a huge factor of uncertainty on economies that depend on winter recreation. How long is the snow going to last in this region? And it also puts pressure on communities and farmers that need reliable supplies of water. So these are real stressors. And then there's health risks. More smoke-filled days, more days of extreme heat, more climate surprises that put stress on us physically and mentally. The vulnerable populations to climate change are people who have existing health conditions, old people, young people, people who live far from services, and people who live in poverty. And at the same time, climate is changing in our region. We're going to have to learn to live with more people. In 2015, Yellowstone National Park had 4 million visitors for the first time. And every year since then, there have been 4 million visitors in the park. I mean, think about it. People are coming to Yellowstone on their vacations because where they live is intolerable. It's just too hot. And this puts a burden on the national parks, on our waterways, and on our backcountry. And more people are moving to this region because they love the amenities. And it's been projected that in 2065, Bozeman will have the population of Minneapolis. Can you imagine the Minneapolis skyline in the Gallatin Valley? So I think we have to face the fact that our responsibility is to flatten the curve, flatten the greenhouse gas emissions, and reduce the temperatures going forward. We need to reach carbon neutrality by 2050 if we're going to keep the temperature levels from increasing only 1.5, maybe 2 degrees centigrade. What concerns me the most about this challenge is I look at these kinds of reports from Yale University on public opinion. If you look at this graph, this is a question that was asked across the country about sort of, do you believe in global warming? And you can see that more and more now accept that global warming is happening, over 72%. And you can see that by all the oranges and yellows. There really isn't a county in the US where the majority of people don't think that climate change is happening. So that's good. And that percentage has been steadily rising. The problem is this graph. Will global warming or will climate change affect you personally? And there, it's the other extreme. Less than 50% think that climate change is going to impact them personally, whereas climate change is affecting everything in all parts of our lives. So there's this disconnect between what people know and how they think it's going to affect them. And it's that disconnect that makes it really hard to address this huge problem that requires everybody being involved, from individuals to cities to states to nations. So we need to do a better job of convincing people that this is an existential threat. And in our region, we have a special responsibility because we live in the last intact ecosystem in the temperate latitudes of the planet. We have huge biodiversity, a lot of diverse species that only find home here. We need to plan for change. We need to recognize that species are on the move, and if they're going to survive climate change, they're going to either have to find some place that's compatible with where they can live, that's compatible for their requirements, or they're going to have to adapt to warmer temperatures, or they're going to face extirpation from this region. So we need to give species the space that they need to accommodate climate change. And we also need to help our communities adjust for climate change. We need to help them prepare for more wildfires, especially communities that are in those lower forests. And we also need to make sure they protect the vulnerable populations in their community, because we don't want to leave anyone behind as the climate is changing. And then finally, I think we need to lean into science. You know, the science of climate change has been pretty darn accurate so far. Yeah, sure, there's stuff we don't know, but we'll figure it out. There's still a lot of research going on all the time. And what we as scientists need to do is to take this information and put it into a form that everyone can understand, information that everyone can understand, and then help people develop plans for action that are both usable and relevant and implementable. So we have the knowledge and the tools to solve this problem of climate change, and we need to act now. We need to get something done in the next 10 years. What we do in the next decade is the legacy that we're going to leave our children and our grandchildren, and it really determines the path that we're going to follow for the coming century. So thank you.
Thank you, Dr. Whitlock. That was a wonderful presentation. And everybody else, the Zoom breakout session link will be going out in the chat soon. So click on that and hop into the Zoom sessions and have great discussion about the information presented.
Is someone going to be asking me the questions, or should I be reading the chat line?
Does anybody know the answer to that?
We're letting the participants of the session talk in breakout sessions individually, and then I think they're going to come back with some questions.
Thank you very much, Dr. Whitlock. That was fantastic.
Thank you. It sounds like people are still getting their thoughts together. Is that right? I'm happy to have any conversations, let alone questions.
Hello, everyone. It looks like we got split into a couple different Zoom links, so just give us a few minutes to get everyone back over to the correct one. We appreciate you being patient. Thank you.
Amy, can you hear me?
Yeah, I can hear you.
Awesome, just checking. Can you see my screen?
Yes, we can. Yeah, thank you for bearing with us through those technical difficulties. Welcome back to the main chat. I'm now going to introduce you to our next speaker, Dr. Tony Hartsorn. Tony grew up in Costa Rica dreaming of snow. So naturally he went to school in New Hampshire where he spent, where he first experienced snow and learned about soil. He then worked as a consultant in Alaska for the next couple of years, where he learned even more about soils and a focus in contaminated soils. That motivated him to pursue a PhD in soils at the University of California, Davis, before postdocing at UC Santa Barbara and Arizona State University. That combination of unique academic experiences cemented his appreciation for how much he still had to learn about soils. So since 2012, he's been learning about soils every day by trying to teach about them here at MSU in Bozeman, in the Land Resources and Environmental Sciences Department. He's always working on promoting #soil culture, and you can help him by tagging all of your soil themed photos on social media with that #. So without further ado, here is Tony.
Hilarious, super awesome. Well, I cannot thank AICHE enough. I am super flattered by the invitation because I'm not even an engineer. So I'll dive right into it. Amy, do you think I'm ready to go?
Yeah, go for it.
Here we go. Hopefully this will work. Of course not. All right. So AICHE did not authorize this title. You can't decarbonize without copperizing, osmiumizing, rhodiumizing, erbiumizing, etc. How to mine our way to sustainable development goals. I mean, that is a train wreck of a title, and I am solely responsible for it. But you'll sort of see why I used it anyway. So I'll have 4 parts today in 20 minutes or so. I'm gonna kind of try to clue you guys in a little bit to how I think about decarbonization. I have 3 reasons why you should decarbonize. I can sort of give you a little preview of that because it's the right thing to do. Kathy would agree, because we can do it. And I'm gonna argue a little facetiously that it's your job. And finally, what is copperization? And that's all a preamble to how do we get from A to B from here to there. So here we go, fasten your seatbelts. This is recorded, right? So you can always replay it if I spoke a little bit too quickly. So I wanted to go back to my photo slide because I'm wearing my coal hat. And for those of you who know, that is a company that was set up 19 years ago by a snowboarder. But I love his tagline, right? Necessities for fine living. I do want to do a weird energy acknowledgement, which is that I don't think this conference happens. My PowerPoints don't happen. You don't get to see me in my amazing Souls teaching lab without the other kind of coal, right? So that's 56 million year old coal when it used to rain 120 inches a year in southeastern Montana. This is going a little bit back further in time than Kathy showed with some of her sediment cores, but just like her sediment cores, all stacks of rock are also time machines. So I do want to tip my hat to your tagline, which is doing a world of good. And because that's your tagline, I thought it'd be appropriate to bring a slightly different angle on the world's carbon cycle. So I teach in land resources. I gave a talk once called The Good, the Bad, and the Ugly of the Carbon Cycle. I only have time for snippets of the good, but I really need you to memorize 6 numbers, okay? So here we go. The first 4 are that the oceans exchange 80 gigatons, billion tons of carbon every year with the atmosphere. That's carbon burped out of the ocean, and then at the same time, it's photosynthesized or in gas right back in. So the ocean's sort of in balance with the atmosphere, broadly speaking, right? Land, the transfers are a little bit bigger, 120 out, 120 in. That's 4 of the 6. Can you guess what's coming next? We also use fossil carbon, right? So coal, oil, natural gas, and that transfer is small relative to the natural transfers that are occurring in the background. That number has not always been 12, as you'll see in some of my other slides. In fact, at one point, it used to be 0, right? The way we know that is going to another time machine. This is a core, a hole drilled into an Iceland glacier. I totally won the lottery with this job because MSU pays me to go on MSU field trips with students to places like Iceland. And so this won't really work, I doubt, because I'm technologically not savvy. This is a video I shot, right, of this core. And I don't know if you can see it, but I got super excited. There are bubbles coming out of this hole, right? And so I totally freaked out. I'm normally a super calm guy, but I was like, wonder what the CO2 levels were in each of those bubbles. And of course, what am I, like a gas chromatograph? I don't know. But I just want to draw your attention over here on the left side of my slide. Let's see if I can do this. Oh yeah, still got the fuchsia thing. Kathy showed a little part of this, but it's an ice core like that that lets us see, what CO2 levels were way back in time. And I'm not going to belabor that point. She did a beautiful setup for this part of the talk. So I don't know if anybody's keeping track, but you've just learned 5 of the 6 numbers that you need to know for the global carbon cycle to understand what decarbonization might mean. And oops, I guess I better not stop share. We can do this, annotate, clear all drawings. And so the 6th number is actually a question mark, right? So I'll draw your attention over here to the right with my cursor. Depending on the choices that we make, as Kathy mentioned, we're coming to a fork in the road. Actually, our choices today will greatly influence how soon that fork in the road comes between these representative carbon pathways. But it's choices that we're making today that are going to influence the size of that drawdown, right? And I'm going to just in the next slide show you that because of that, there's a lot of uncertainty, right? I mean, Kathy said we should be living with uncertainty, and that's so that we don't know which of those pathways we'll be on. Hope that makes sense. So I've been really helped in preparing this talk by a report that just came out. Total blue ribbon panel, and it's called Accelerating Decarbonization of the U.S. Energy System. I put a little URL shortener in there. It's just 2021 Decarb with a capital D as in dog. Again, blue ribbon panel, National Academies of Sciences, Engineering, and Medicine. But in there, for this talk, I think the most important thing for me to note is that they've said there's a social contract for decarbonization. Has 8 parts. I'm trying to see them through my video feed. There should be a joint responsibility across stakeholders. We should honor the contributions of energy workers, should acknowledge interdependence between stakeholders. There should be maximum transparency. We should engage diverse communities. We should financially support some of those communities who maybe are not as well off as others. This one's important. We should distribute the costs, benefits, risks, and burdens of decarbonization fairly across all Americans. I might riff on that a little bit, and I'm just going to point something out. I don't know this to be a fact, but this one, the equal burden, but also opportunity, that leveling of a playing field, as it were, I don't know who came up with this terminology. It's amazing, but I do know one member of that blue ribbon panel. And she's at the very bottom of this screenshot that I took when I was in the webinar. So the panel is led by this Princeton dude, Steve Bacala. He's been involved in thinking about carbon for a really long time. But Julia is one of our own, MSU Earth Sciences, and she's now the director of the Institute on Ecosystems, which Kathy used to hold that position. So really great. Again, I don't know if the social contract is Julia's work, but she's been arguing recently that there's some tectonic shifts in the energy geography, especially of the Northern Rockies that are unfolding. I'll come back to that. Okay, why decarbonize? I already gave this away. It's the right thing to do. We can do it. It's your job, right? So let me keep going. So on that same trip to Iceland, MSU field trip, we also stopped in Germany for the UN climate change conference. And my students were really impressed that, oh, I thought climate change was just about carbon dioxide, methane, nitrous oxide. And I'm like, no, it's actually all about these 17 sustainable development goals. Super aspirational. We want to get there by 2030. The first one is no poverty globally. Second one is zero hunger, and they just get better from there. Okay, so my students were completely surprised by that. But the other reason we should decarbonize because we can, right? So that same guy, Steve Bacala, Rob Sokolow, 2004, they publish a paper that I've really gravitated to in my teaching called Stabilization Wedges, how to solve the carbon and what they called in the paper, the climate and the carbon problem of the next 50 years with current technologies. I actually emailed Rob and I was like, God, dude, thanks so much for your stuff. And he wrote me back, he emailed me back, which stunned me. Hey, thank you, I will respond. I want to give credit where credit's due. My associate, Dr. Roberta Hutinsky, was nearly entirely responsible for all the teaching stuff. So from now on, whenever I mention Hutinsky, that's who's involved. So what's a stabilization wedge? I mean, the basic idea, and Kathy has really set this up beautifully. You think about where we're headed, and that's, it gets the initials here, business as usual. We might be aiming for a tripling of pre-industrial CO2 levels, right? And then the idea is that if we could just stabilize emissions with something called the stabilization triangle, we might avoid doubling to 560, right? She just mentioned we're at 415. The coolest part about this is that triangle can be filled with wedges. And I mean, it's not going to stretch your imagination, but I call this pick your favorite part of the world to plug into. Construction engineering, we've got challenges for you. Food system, we've got challenges for you. If you're a forest soul guy, kind of like me, we've got projects for you. Methane management, we actually have global leaders in methane management right here in our very own Bozeman. So I love this, right? Because it's sort of inclusive, big tent, and everybody gets to be playing a role as part of the solution. I do want to make a quick note. This paper was published in 2004. And if you were to plot our emissions last year at 12 gigatons of carbon per year, we're off chart, okay? So anyway, maybe this whole thing about, this is why we should decarbonize didn't quite work out the way that this Princeton group had thought it might. Here's the other reason that you should decarbonize, though. It's because it's your job. I don't know if you knew that, but the essential elements of a Montana State University education involve copper, osmium, rhodium, and erbium. And if you're like, I was with you right up until that point. Well, there's a reason I picked those elements, right? It's because they spell core. And the whole idea is if you're doing your job as a student, then hopefully you're learning how to be a more effective communicator. You're learning how to be a clear thinker and a sharper problem solver. And then, most important, of course, you're learning how to be a most insightful local and global citizen. I'll come back to that in my last slide. Okay, so what's copperization? This one's really simple and not very involved. So the way that I want you to think about copperization is, what are the metals that we need for climate action? As the world decarbonizes, it's my conviction that we're going to need a 10 to 100-fold increase in metal mining. Why? Because I don't know if you knew, but copper, like this chunk of rock. Of course, I took the photo on another MSU field trip to White Sulphur Springs, 2 hours from Bozeman. So this rock has 18% copper in it. We need that copper for things like wind turbines. So every single turbine is a copper hog. And it's not just copper, it's also an aluminum hog. Oh, and it needs some rare earth metals as well, like neodymium. And by the way, that was a really small wind turbine. We now have 13 megawatt wind turbines. Okay, so another MSU field trip, another photo. This is one turbine, 2.5 megawatts, north of Reed Point between here and Billings, because these wind farms are sprouting up all along the high voltage transmission line that used to pump only coal-fired electricity along it. Anyway, this one I've predicted, would love for you guys, you're the chemical engineers, say, no, your math is all wrong. You should really learn how to do math, which is true. Anyway, 4 tons of copper, 1 turbine. Okay, how do we get from here to there? And the way that I'm going to structure this part, we're going into the home stretch, sort of. I mean, hopefully I'm halfway through, although I lost my timer, of course. So I'm a super optimistic guy for 4 reasons. I'll lay those out. The first reason is I think our messaging has gotten a lot better. I think we've improved our ability to recruit folks. So remember that Princeton report came out in 2004. Well, that's been updated for 2020. And I love this frame of thinking about gas, food, lodging. Used to be an old road sign. I mean, used to be you could see a little icon for a payphone, but of course, all those have been gotten rid of. How do we remake our transportation system and the fuels that those require? How do we remake our food systems, you know, and the fossil carbon that requires? Think fertilizer. And then how do we remake our lodging, our built infrastructure? All decarbonized, right, of fossil carbon. This group, again, the report just came out last year. Our analysis shows that a global zero emissions economy can be achieved by mid-century without relying massively on offsets from nature-based solutions. I think our next speaker will be addressing that, or negative emissions technologies beyond the transition period. And I mean, they're just like, go, because it's technically feasible. That's the switch on the left. And it's economically feasible, right? It's the switch on the right. And then you could be like, well, what's the fine print? Look, full decarbonization, right? Another global report, only 0.5% of global GDP. What is that? Well, you guys all know, like global GDP is $86 trillion. So, you know, 0.5% of that is only $430 billion. Like, what's the big whoop-de-doo? We've been talking about trillion-dollar aid packages just in the US, not globally, right? Well, second reason I'm optimistic is, let's just think about this for a second. It's technically and economically feasible. Well, then what's the holdup? And I think it's because, this is why I'm optimistic, this is a totally self-serving part of the talk. I actually think we need an educational campaign, right? We need to, again, do that social contract, and we need an educational campaign. So this is reason number 2, I'm optimistic how to get from A to B. So it's hilarious, right? I'm a teacher, so of course I'm gonna be like, dude, where's the education? Where are the educators in this? And of course, this decarbonization report in February completely anticipated me calling for, let's have a big decarbonization educational campaign, because they wrote, and I flashed through this earlier, this is the social contract for deep decarbonization, right? We've done this before. Such a contract cannot be assumed to exist at present, nor will it result from naive programs that seek only to, quote unquote, educate the public. Like, I mean, all my colleagues know I'm a numbskull, but like, this is perfect, right? So I am not going to attempt to naively educate you, but I am going to remind you of some of the things I've learned as a teacher about some special Montana angles for decarbonization. So remember coal? Yeah, so here's this time machine of coal. This coal is really special globally, right? So this is called low sulfur Powder River Basin coal. So if you don't know where the Powder River Basin is, again, I'm not trying to be a naive educator. It's in southeast Montana and northeast Wyoming. Powder River Basin coal, we are the Saudi Arabia of coal globally, okay? So it turns out 50 years ago this October, there was a study called the North Central Power Study. And that was really interested in thermal power plants with high voltage transmission and how do we get all this juice, coal-fired electricity, to load centers. And those are mostly over in the Midwest. We were just talking about Minneapolis in the previous session. So, you know, they were a big city back then, so, but they needed electricity. So why don't we like set up some coal plants? This study, has classic 1971 graphics. I mean, how can you not love this? It's just stylistically brilliant. But inside this study was this map. And this map proposed that we build 21 coal-fired power plants in Montana. So for those of you who are tracking the bouncing ball right now, that's 20 more coal-fired power plants than exist today in Montana. Colstrip, coal-fired power plant, that's number 9 there in that dot, is the only one that was actually ever brought online. But originally, there were going to be 21. What happened to the other 20? It turns out it's a really cool Montana story. So what ended up happening is a bunch of ranchers got together and said, not in my backyard. And so the Northern Plains Resource Council, which is a Billings-based NGO, was formed to help these ranchers organize and say, whoa, 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 we think the burdens of coal-fired electricity are not being shared equally, for example, except they did this 50 years ago. How do you like that? Here's another line that I had to draw attention to from the report. Really, another blue ribbon committee. They know they could identify no overriding legal obstacles to development of 21 large generating complexes. So some were going to be twice the size of Colstrip, some were going to be smaller than Colstrip. And that's really interesting because I bet you when Montanans read this in the report, they're like, well, let's create some legal obstacles, like maybe a new constitution. They did that. 1972, Constitutional Convention, they rewrote the Montana State Constitution. And in that Constitution, it says, the state and each person shall maintain and improve a clean and healthful environment in Montana for present and future generations. How do you love this line? You know, the legislature shall provide remedies for the protection of the environmental life support system from degradation. I mean, this was super farsighted 50 years out. And I hope you'll use it as a model. Okay, the other thing is like, we're a mining state. If you don't think we're a mining state, dude, just look at our state seal. Right there in Spanish says oro y plata, gold and silver. And then if you're to fly over the state and say, well, how many mines are there in Montana? Dude, our state is 100% mine, almost. I mean, the way that this graphic is assembled. I know, most of these are gravel mines, but we have our fair share of hard rock mines and soft rock mines like coal. Okay, so of course, all those mines have generated some opposition campaigns. This particular campaign is really interested in saying, you know what, why are we burning dirty coal in Colstrip? Could we just like zero that out? Because right now Colstrip has 2 of 4 power plants working. This one is anti what some people call the Smith River mine. That's that copper mine, that the 18% copper sample that I showed you. And of course, I love their tagline. The Smith River is not a location for another failed mining experiment. And then, you know, this one is the most recent victorious campaign. It was called Yellowstone is more valuable than gold. And basically a group organized and said, you know what, we should not be mining for gold on the doorsteps of Yellowstone National Park, right? So, I mean, where there are mines, there's opposition. And so I get that. And Montana's familiar with that, right? Sort of how to have these conversations. The third reason that I'm optimistic about this, getting from to decarbonizing, is hidden work by the same Princeton group, right? So officially they're known as the Carbon Mitigation Initiative. And again, this is Steve Bacala, Rob Sokolow, and Roberta Hatinsky. And in their work, they actually said, you know what? We need a new intellectual domain. And they called it prescience, the art and science of looking ahead. You know, we need a new word to describe this new domain. We have scarcely begun to ask, what are we on this planet to do? And I would really put that in front of all the students on this call. What are your goals and what are your responsibilities? You know, they have a lot of arguments. Well, why might a discipline of prescience, looking ahead, be helpful? You know, checklist. I love these questions. We will struggle over the goals. What are the levels of risk? How much intergenerational and intra-generational equity is there? How do we assign responsibility for ecosystems and other species? And then we'll struggle over processes. Who gets to decide? And here are 3 questions for you. So I don't know if you heard, but last week, this study was canceled, right? It's a Harvard study in Sweden. They were going to drop 5 pounds of dust, rock powder dust, into the atmosphere over Sweden. Why? Because you know, they were going to study solar geoengineering. Can we block the rays, the sun's rays? Who gets to decide whether we study or solar geoengineering? By the way, this was canceled, right? Who gets to decide where our ingredients for our electricity will come from? I mean, I hope you student leaders will get to decide, but make sure that everyone's invited to that decision-making table. And then finally, I mean, I'm a huge fan of Wally McRae. So he's a coal strip rancher, very opposed to coal-fired electricity. But he wrote a poem called Things of Intrinsic Worth. And I'm really sorry, I don't have time for you to listen to it, but it's well worth 2 or 3 minutes. He's actually recited it for us in coal strip in front of another MSU field trip. But I mean, we can ask the question, who gets to decide the value of things of, quote, intrinsic worth, unquote? And I mean, the Princeton group would argue what has seemed too hard becomes what simply must be done, right? So that's their sort of encouragement. My last source of optimism is that your AIChE, the global home of chemical engineers, does not have as your motto, doing yourself good, right? I love it that you guys are plugging into this with as much enthusiasm as you can muster. I'm also glad this is not your tagline, doing your state good, because how much would it help Montana if Alberta, Saskatchewan, British Columbia, Idaho, Wyoming, all of our neighbors felt like they were unfairly sharing in the burden of decarbonization? It wouldn't. Extra encouragement for you guys, and I'm glad you're plugged in. We're going on a quick field trip to Peru, northern Peru. There's a town called Cajamarca. This city has been called the city where 2 worlds collided. And it's because it's the world where the last Incan emperor, Atahualpa, they were amazing miners of the Andes for hundreds of years. But this encounter happened almost 500 years ago with the last Spanish conquistador. And if you cruise around the streets of the city, you'll see graffiti. And I've highlighted it here in the lower left. Water, yes. Mines, no. And then I was teaching courses down there in a Fulbright. So these are my shell shock students in a classroom in Cajamarca. They want to be the leaders in their communities for decarbonization, but they don't want the metal ingredients to be coming out of their backyards. How do you like that? And they were shocked when I was showing all these anti-mining campaigns. So for example, I do trust that you guys will be able to answer this question after you graduate. Okay, so the Smith River's not the right location according to this one campaign. Oh, but you guys can figure out where the right location is, right, for the next mining experiment. Look, I understand that as you look at this periodic table of elements and you understand the agonizing trade-offs between the different elements here, and we've talked about like carbon and copper, just to name 2 in today's talk, you're not going to be able to make sense of any of these elements unless you bring in one other element as an advertising campaign mentioned 15 years ago, right? And that's the human element, right? So this is not my campaign, it's Dow Chemical Company's The Human Element campaign. And I guess where I would close, this is my last slide, is that I am so grateful for your tagline, because it's not doing 1/2 of a world of good, or 1/4, or 1%, or 1 part per million of a world of good. Your tagline is doing a whole world of good, and good luck with that.
Thank you, Dr. Hartsorn, for such a truly incredible speech. I think you did an amazing job of unpacking such a complex topic like that. And I think we have a lot to unpack going in here to our breakout rooms. So there's going to be a little link in the chat box here that'll direct you to your breakout room for this next session. And then after that, we'll all meet back here. Thank you so much.
Welcome.
Okay, so for the next part of the presentation, there are only select people that we were able to fit into this part. So if you have the link in the email that you originally sent, now would be the time to click on that link. And if you do not have that link, you can come back here in about at 5:35.
At 5:35. Can I just stay on here? I can do other things. So can I just stay on here or do you need me off?
I think it would be fine if you stay on, and actually closer to about 5:45 is when we will return to this meeting for those that don't have access to the other one.
Okay. I'll just stay on and work on other things and holler when you're ready.
Great.
Okay.
we'll be waiting just a second for a couple more people to trickle in, and then we will get on with our next speaker. All right, so our next speaker is Will Erickson, and Will Erickson founded Western Sustainability Exchange in 1994 to protect the incomparable landscape and way of life of the Northern Rockies, and to do so in ways that strengthens rural economies. Erickson has been WSE Executive Director since its inception. Erickson's expertise is in regenerative agriculture and the use of market-based conservation strategies to achieve environmental protection and economic development goals. She specializes in strategies and incentivize agricultural and food service business to convert to regenerative and sustainable practices. And with that, I would like to welcome Will Erickson.
Hi, thanks so much for including me in this conference. Like Tony, I'm not a chemical engineer, so I hope what I have to say will prove useful. I would like to share my screen now, so hopefully this is going to work. Can you all see that, or can somebody tell me if you can see that? Okay, cool. Let's see. Okay, here we go. So as Nick said, I'm with Western Sustainability Exchange, and our mission is to preserve the best of the West, the wide open spaces, the wildlife habitat, and our farming and ranching heritage. And we do that by providing sustainable solutions that promote environmental stewardship and rural economic development, or prosperity rather. Our primary focus area is helping ranchers convert to regenerative practices. And these are practices that improve soil health, increase plant diversity and vigor, strengthen drought resiliency, protect water quality and wildlife habitat, increase biodiversity, and sequester carbon through healthy grasslands. Some results of our work over the years have been, we've protected 1.5 million acres through regenerative practices. We've worked with over 1,500 ranchers to use regenerative practices on their operations. Because of our connections to different market outlets, we generate about $1.75 million in annual sales for the farmers and ranchers in our program. And through our new Montana.
Lil?
Yep.
So it looks like our slides have frozen here.
No.
Maybe if you reshare your screen, I'm not sure.
All right, so I will, something's weird here. Okay, I can't get to stop screen share. Well, darn. I can't seem to stop screen share. It's not letting me do that.
Is it at the top of your screen there?
It is at the top of my screen. So I have two screens going. Maybe what I should do is unplug my big monitor and see what happens there. Whoop. There we go. I was using the big monitor so I could see better. All right, we'll try it again. So that's still not letting me. Oh, this isn't ideal, but what are you seeing on your screen?
Yeah, so we can see the slide. It just also has that bottom bar and
all the other
the
stuff.
next slide. Yeah.
For some reason, I don't understand why it won't let me. But when
maybe the use slideshow button at the top there.
Ah, there we go. Well, no, maybe not. Sorry, everyone. Shall we just try it again? Let's see. Here we go. Maybe. How's that?
Perfect.
Okay. So where did I lose you all?
We were actually at the title still.
Oh, you're
slide-wise,
still
at
at the
least.
title,
Yeah.
right here. Oh, okay. Well, I won't, I'll just rush through these. We might spend just a minute on this, though. Regenerative practices do improve soil health, increase plant vigor and diversity, strengthen drought resiliency, protect water quality and wildlife habitat, increase biodiversity, and then sequester carbon. I already told you guys that. So we are a nature-based carbon capture program, and we are relying on grasslands to sequester carbon. And there's a growing body of science that says that grasslands could prove more resilient than forests in their ability to sequester carbon, especially in the face of changing climatic conditions. And that's important because grasslands comprise over 40% of the Earth's surface, as you can see from this slide. They're second only to oceans in the amount of surface area on the planet. And Western ranch lands contain some of the most significant grasslands left in the United States. Unfortunately, 80% of the world's grasslands are in poor to marginal condition. And overgrazing is often blamed for this, and it's really not overgrazing as much as it's selective grazing, overgrazing, which means that cattle have a tendency to graze the kind of plants that they like, just like we do. You know, we eat the foods that we prefer, and so do they. And so they can overgraze those plants and undergraze plants that they don't want. And they can do it to such a point that they destroy the root systems, and then you get a lot of bare ground. So you have less plants, less diversity, you have minimal soil cover, more bare ground. And a lot of that reason is because these pastures are not left to rest after the cattle have been in them. So what we want to do is really increase the ability of grasslands to photosynthesize. And so I'm sure all of you all know this, but in photosynthesis, plants pull CO2 out of the atmosphere, release the 2 oxygen atoms back into the air, draw the carbon atom deep underground through its root systems, where it's considered sequestered. There's lots of debate over how far it has to go underground to be considered sequestered, but that's basically the process. And effective sequestration depends really on the health of the soil, of the plants, of the roots, and abundant and diverse microorganisms. So our program, the Montana Grasslands Carbon Program, is designed to use the voluntary carbon market as an incentive for ranchers to use regenerative practices. And our goal is to sequester 500,000 tons of carbon annually on 1 million acres and do this within 5 years. We are in partnership with a carbon project developer called Native Energy. And Native Energy's role in the partnership is the connection to the carbon markets. And they are an international carbon program developer. They provide the carbon offset payments to the ranchers. They also provide upfront financing for any infrastructure that may be needed to jumpstart the project. All of this is to produce additional carbon sequestration or additionality. Our role is implementing the project on the ground. So we're a regional regenerative ag nonprofit. We organize workshops and webinars with some of the world's top experts on soil health, regenerative grazing management, low stress livestock management, the role of range riders, among other things. We also offer one-on-one technical assistance to ranchers. We are developing ranch management tools. We are developing right now a regenerative ranch assessment that ranchers can use to see where their ranches fall in the all the different protocol parameters of a regenerative operation. And then we're creating a resource management dashboard that ranchers will be able to use to access the best scientific information to inform their management. And lastly, we connect ranchers to different economic incentives and markets. And the carbon market is an example of that. Together, WSE and Native Energy work on a rigorous soil sampling program. So we sample for soil carbon, bulk density, water infiltration rates, soil moisture, the percent of cover of both live plants and bare ground. And this serves as a valuable baseline for the measurement of soil carbon on current measurement of soil carbon on participating ranches. Our primary strategy to increase sequestration is intensive rest, short duration, which means frequent movements, high density grazing practices. So that means if you look at a conventional operation, generally what they do is they turn the cattle out for the summer on these large pastures. And so the cattle spread out and they hang out in the riparian zones and they eat what they want. They don't eat what they don't want. And so you don't get a lot of herd impact. You certainly don't get the impact that this region would have gotten when the bison moved across the landscape. And the region evolved with millions and millions of hooved animals moving across the landscape, moving all the time and in tight herds, mostly because the predators are keeping them bunched up. So in regenerative grazing, what a rancher does is they do a planned grazing movement where they would take a large pasture and break it into much smaller paddocks, primarily through the use of electric fencing, but you could also use range riders to just keep the cattle moving, bunched up and moving. And so high intensity means keeping the cattle in tight bunches and moved often, and then leaving the paddocks or the pastures for long periods of rest, however much rest a pasture needs in order for the root system to be strong and the plant vigor to be healthy. Some of the benefits of this is that you can, the other thing you have to do is fence off the riparian zones. And so riparian zones can come back to health pretty rapidly. Here's a picture on the right. You see the riparian zone has basically, there is no riparian zone. You have a lot of bank cutting. The stream is wide and shallow. On the other side, in just a couple of years, the stream is narrowed. If you could look down on it, you would see the stream is narrower, deeper, cooler water, which is better for fish and aquatic life. And the riparian zone is starting to come back. That's one of the impacts that we really want to see. The other picture on the right, you see cattle that have been in a pasture and they're just about ready to move off of it. You see the utilization is very different than in conventional grazing. It's pretty well used all the way across. You see lots of manure piles, and that's a very good thing. It probably contrary to what many of you think, but you want that manure on the ground, and you want the urine, and you want those hooves breaking up the soil capping, just as the bison did when they moved across the landscape. And the result is you get, if the pastures have been given enough rest along with all the nutrients it needs, then you get really great grass production, as in this picture. So that's what the above ground looks like as far as results. Below the ground, you see a deepening of the root systems. You see more topsoil. You see little trenching where there's many more microorganisms, and the microorganisms play an incredibly important role in carbon sequestration. So this is what we call the dreadlock root system, and this is a very good root to get. If you pull up a plant and it has really smooth roots, then it doesn't have much microorganism activity, and it isn't really at its maximum potential to sequester carbon. The more you can create healthy soil and conditions for the microorganisms, that's really where the magic happens in terms of carbon sequestration. And it's called the mycorrhizal sheath on these roots, as you can see, and they look like dreadlocks. That's why we're calling them. And these sheaths are really important because they protect the plant, the soil moisture for the plant. They also buffer against changes in soil chemistry like alkalinity, acidity, and they help these roots lengthen, and then the mycorrhizal system to reach the minerals that are much farther down in the ground, and that brings those minerals up to the plant, and that creates a healthy plant system. And as it's doing that, it's moving that carbon atom farther and farther and farther, deeper and deeper and deeper into the ground. So a big part of the project is determining additionality. And additionality basically means what are the processes that would increase the amount of carbon over what is in the baseline condition. And so that's why we do all the soil sampling, is to determine the current baseline condition. Then we work with the ranchers to look back and say, all right, what was the management that you were using that produced that carbon level? And so that's documenting past management practices, very important for additionality. And then the ranchers look at what do they want to do? What are their plans for the future in a lot of detail, and pasture by pasture detail. All of this goes into a predictive model. So the model takes past management, current carbon levels, and then the planned changes to management. And it's sophisticated enough that it can predict the amount of additional carbon that could be sequestered if these management practices were implemented. It also takes out or removes or takes into account the amount of carbon that the cattle themselves would be emitting. So you get a true measure of additionality. All of this information goes to Native Energy in the form of a letter of interest. It documents past management practices, new management practices, and it also identifies any infrastructure and the costs of the infrastructure that ranchers might need to jumpstart their projects. So fencing, water developments, range riders, education on regenerative practices, whatever it is that they need, all goes into a letter of interest. So the letter of interest, together with the outcome of the predictive model, will determine if the additional carbon is enough that it would warrant a contract with Native Energy, because enough carbon would be generated that it could be sold as a carbon offset credit. So they enter into a carbon contracting process with Native Energy, 30-year contracts, and it's between Native Energy and the ranchers, but we are very involved in that whole process. In the contracting, the ranchers commit to keep the land in grazing. And even though it's not a conservation easement and perpetual protection, 30 years is a long time. And that means that that's what's going to be happening. Grazing is going to be on there, no development, no oil and gas leasing, only grazing. And that they commit to using regenerative grazing practices. They submit annual grazing plans and submit annual post-grazing reports about how did the plan work? Did it work? What did you have to do? What were the results? And they also allow sampling and monitoring on their ranches. As far as payments go, Native Energy has what's called a help build fund, which provides upfront financing for the infrastructure if ranchers need it. And it's generally on a 5-year term. Basically, they provide the amount of money that would have been available in 5 years, and they get paid back in carbon. So the ranchers don't have to pay back any cash money. They pay it back in carbon over 5 years. And then after 5 years, they get paid annually based on the amount of additional carbon they're sequestering. If they don't need the infrastructure support, they can have a vintage agreement with Native Energy where they are paid annual carbon offset payments based on the additional carbon levels. One of the things about our project is, and not all projects have this, is we're going through a very rigorous validation process. We're working with Verra. It is the largest voluntary greenhouse gas program standard in the world. And once the validation is complete, Verra will issue tradable verified credits that can be sold through the carbon market to individuals and companies that want to offset their carbon emissions. And we are very close we're at the very final stages of getting validated. So the carbon credits coming from our program are considered very high value because of their outstanding co-benefits of improved ecosystem function. We don't need any mining here to help with the climate change issues, because what we are doing is improving the health of the ecosystem. We're protecting fish and wildlife habitat, improved water quality and quantity, strengthening drought resiliency, and very important. We're increasing biodiversity, and there are many predictions about what climate change could mean to biodiversity, and they're pretty grim. And we could lose over 50% of the species to climate change. So we feel like our project is incredibly important because we're protecting critical habitat. And our region is not only the last intact remaining ecosystem, a temperate zone ecosystem on the planet, we also have wildlife resources that are really second only to the resources of Eastern Africa, like the Serengeti. So incredibly special place that we are lucky enough to live. And so we're committed that our program not only sequesters carbon, but also protects biodiversity. The current buyers for the carbon credits are Xanterra Parks and Resorts. They're the largest concession management company in the country, and they manage the concessions in Yellowstone and Glacier, and they've been a longtime partner of ours. So they were the first buyers. Trillium Asset Management, Stonyfield, New Belgium Brewing. So when you guys are drinking beer, I hope you're drinking New Belgium and you let them know why. Allbirds Sustainable Shoes, Reformation Fashions, Everlane Clothing Company, and those are sustainable fashion companies. And Gucci just came on at the beginning of the year. And while we really appreciate those large companies, and I do want to go back and show you, this picture is, we did a very special tour for ranchers and 7 big companies to show them how this is applied on the ground, what happens beneath the surface of the ground. We did these big trenches that are 10 feet long and 4 feet deep, and you can really see what's happening under the surface of the ground. And we were all learning together, and it was really great. It was very exciting to do that, and we plan to do a lot more. But we really want to have people here be able to purchase the carbon credits. We're not quite there yet, but our hope in the next few years we would be. And that would be local restaurants, Montana resorts, regional businesses, churches. We were just approached by a group of 100 churches that want to buy carbon offset credits. We're very excited about that. Universities, MSU could do that, and you could do that. And we hope that all of you are really looking at ways to reduce your carbon footprint, but where you can, buy carbon offset credits from this project. Our current status is we have 4 ranches that have signed 30-year contracts at 34,000 acres, and we're sequestering 20,000 tons of carbon annually with the estimated 600,000 plus tons over 30 years. By the end of 2022, we'll have 10 more ranches, 200,000 acres, capturing about 90,000 tons annually and over 4 million plus tons over 30 years. Our 5-year goal is to have 50 ranches, 1 million acres, capturing 550,000 tons annually, 20 million tons over the 30 years. And that would offset all of the emissions of Montana households when we can get to that level. And we really think we can in the next 5 or 6 years. So that's our program. And I thank you very much for the opportunity to share it with you and to also to learn from the other speakers. I wish you all the luck in the world in what you are doing. And I guess we're not even going to have questions. I'm not quite clear on that, but if you had questions, I'd answer if I could. Thank you.
Thank you so much, Lil. That was a great presentation, and it's great to hear about some local efforts for carbon sequestration. I believe we will now be moving into breakout sessions where we'll talk about this, and then immediately after the breakout sessions, we'll just have a quick debrief for the day. And then the questions, we'll actually be doing our panel Q&A at the end of tomorrow.
Okay, great. Thank you all very much. Good luck.